Hello, welcome to Train Signal. This is the Configuring Intrusion Prevention lesson in the Forefront Threat Management Gateway 2010 training course. So what is the network inspection system? That just happens to be the topic that we'll discuss first in this lesson. After that, we'll talk about how NIST is updated. NIST is a signature-based system that will allow you to download new definitions from Microsoft on a periodic basis. We also have to learn how to create exceptions to NIST policy, or Network Inspection System policy. After all, rules are not always black and white. Most importantly, we got to make sure that the Network Inspection System operates. So, you'll learn how to test your NIST implementation for Global Mantics and for your own environment. Whereas NIST is a signature-based system, Threat Management Gateway also includes a behavioral intrusion detection system that we'll discuss next, and then we'll wrap up with some behavioral protection notes. Global Mantics has a growing concern about the possibility for outside or unauthorized people making their way into key internal systems without anyone knowing. Although systems are regularly patched, these patches take time to create, and Microsoft often discovers new vulnerabilities weeks or sometimes months ahead of being able to patch them. The firewall only protects against those obvious threats, and it's very much rules-based. To mitigate against additional threats, Global Mantics will implement the intrusion prevention system known as the Network Inspection System. By the end of this lesson, you'll understand how intrusion prevention complements Threat Management Gateway's firewall functionality, and you'll get an overview of how to manage the Network Inspection System service. So what is NIST? This is the signature-based intrusion prevention system, which basically says that the system will look up particular signatures as they come across the network in an intrusion prevention database, and if it sees a matching signature, it will block the traffic. This is a relatively simplistic approach, but it's a good approach when it comes to blocking vulnerabilities before there's actually a real patch for that vulnerability. Microsoft can react much more quickly with a signature for NIST than they can with a patch for an operating system. After all, a NIST signature is just a signature. An operating system patch requires all kinds of testing, regression testing, make sure it doesn't break other things, and it can take a lot of time to code around an issue. Basically, NIST helps protect hosts against new vulnerabilities as they're found. This can help reduce the opportunity window between the time when a new host exploit is found and that exploit is patched. Bad guys can react faster than the good guys, so an intrusion prevention system can help the good guys add a line of defense. What you're going to find is this is a pretty good feature, and it's very, very simple to configure and manage. In fact, it's already enabled by default in our implementation, and I didn't have to do anything. Basically, it's ready to go and already protecting the network, and you're going to see this in action in a few minutes. As you might suspect, NIST does not work on Microsoft Patch Tuesday schedule, such as Windows Server Update services and Windows Update. NIST provides an interim defense while Microsoft makes efforts to patch a core vulnerability, and definitions are downloaded on a regular basis. Here's how it works. A new vulnerability is discovered, and that vulnerability is then reported to Microsoft. Based on this information, Microsoft creates a new NIST signature and tests it to make sure that there's nothing glaring that's going to break as a result of the NIST signature. Once these tests pass, the signature is released and Threat Management Gateway downloads the update. Immediately, network traffic that uses the network inspection system is now protected against a vulnerability. This is a good thing. This is a very fast way for Microsoft to be able to respond to potential problems. We're going to go over to the Threat Management Gateway system for Global Mantics in just a minute, but let me talk about how NIST definition update settings are managed. First of all, you have to choose an update action. Do you want to allow the network inspection system to automatically check for and install its own updates? This is the default option, and it's the recommended option to keep your system in peak operating condition. However, it is entirely possible that Microsoft would release a NIST definition that breaks something. So some particularly sensitive organizations may want to move on to the next option, which is to just check for definitions. This allows you to check for definitions and do some research on new definitions before you install them to make sure that others are not having problems with a definition update. And finally, this is not recommended, but you can have no automatic action taken and simply manually manage NIST settings all the time. The next, manual error threshold in days. After how many days of no updates do you kick off an error in the Threat Management Gateway console? By default, if more than 45 days have passed and there have been no NIST definition updates or NIST signature updates, there's going to be an error raised in the Threat Management Gateway console. Next, overall global response policy for new signatures. The Microsoft default policy, detect only policy, or no response. We'll talk about these a little bit more in depth soon, but I think detect only and no response are pretty self-explanatory. The Microsoft default policy is to detect and block traffic, by the way. Now, let's say that you do download some updates and all of a sudden something just goes all to heck. You can actually revert back to an older setting of the NIST definitions because Threat Management Gateway allows you to choose which version of the NIST definitions to use in production. We talked about some of the things that you can do with regard to managing signatures, and you can configure the network inspection system to simply detect or detect and block the entire range of NIST signatures as a block. Now, what that means is, do you want the network inspection system to simply, as a whole, find issues, or do you want it to find and block based on what it sees? You can also manage this on a per signature basis. So you can open up signature properties and then enable or disable individual signatures. With individual signatures, you can also configure an individual signature to just be detected or detected and blocked. So it's a pretty granular system as well. As I mentioned, the network inspection system is enabled by default in our installation. There are always exceptions to policy, and the network inspection system is no exception. You get it? You can decide what you would like to exempt from NIST, but there are some things that are exempted by default. Specifically, as your users browse to resources located at Microsoft.com, Windows.com, and WindowsUpdate.com, their traffic will not be put through network inspection. That is because those domains are exempted from being inspected. You can also choose to exempt entire networks. So you could say that any machines that are from which traffic is originating from, say, your perimeter network is not going to be subjected to the network inspection system. So you can say, based on origination or source, that traffic will not be inspected. You can also exempt individual computers or groups of computers, which might be useful if you have to be able to test things, as well as address ranges and entire subnets. Testing the network inspection system is a key to making sure that everything is up and running as it should be. At this point, we're going to go over to the GlobalMantic environment, and we're going to do two things. First, we're going to take a look through the various network inspection policies that are put in place, as well as the network inspection's configuration. And we're going to then move over to a desktop, and we're going to test the network inspection system with the use of this test URL. If you're implementing the network inspection system in your own environment, this is a standard URL that you can use to make sure that the network inspection system is operating as expected. It's a safe way to test the network inspection system without having to try it against a real threat. And here we are over at the Threat Management Gateway console, and I've selected the Intrusion Prevention System area, and right now we're looking at the Network Inspection System tab. In the right-hand side of the window, you'll notice we have a number of items. We have Configure Properties, Define Exceptions, Set All Responses to Microsoft Defaults. This is where Microsoft will, now I said before, it's sort of a blanket thing, and it is a blanket thing to a point. Not every single signature will be a detect and block. The Microsoft defaults means that you'll set it back to what Microsoft recommends for a particular signature, which would be either detect or detect and block. Or you can set all responses to detect only. I'm going to choose Configure Properties so that you can get an idea of exactly how this all works. Notice on the first tab, Enable NIST is already checked. That means that the network inspection system is up and running and actively protecting the GlobalMantic network. Going to the Exceptions tab brings up the same thing as if I were to click Define Exceptions over in the Tasks area. And you'll notice again we have a number of sites that are exempt from the network inspection system. And if I click the Edit button, you're going to see that there are actually a number of sites: Microsoft.com, Windows.com, and WindowsUpdate.com, as I mentioned before. Here I can add, rename, or delete things from this list. Or I can go over here and add other elements from the Threat Management Gateway environment if I like. Next up, we have definition updates. So what do I want to do? I want to check for and install definitions. This is the recommended action, as I mentioned before, so we're going to leave that in place. We check every 15 minutes. You can check from every 15 minutes to every 4 hours. Notice that's the only range you have. You can't say I want to check once a day or once a week. You have to go every 15 minutes, 30 minutes, 45 minutes, 60 minutes, or 4 hours. And again, 45 days is the default trigger for an alert if there are no new definitions in that period of time. Here, I mentioned before, the new signature set configuration is what we want to have happen when a new signature set comes down. Do we want the Microsoft default policy, detect only, or no response? We're going to leave the Microsoft default policy in place. Clicking the version control button brings up the ability to allow you to select a particular set of signatures. So if I like, I can revert back to an older set of signatures, 6.8.10, 5.19.10, or I can upgrade to a later version if I had reverted to an older version earlier. So we're going to deselect this because we want to keep in place what we have right now. Now we have a tab here also called the Protocol Anomalies Policy, and this basically checks if network traffic is working in a way that it's supposed to work. There are times when people will use a protocol in a slightly weird way, but it's actually legitimate. Enabling this feature, basically choosing it to block, can break things. So you have to be very careful and really have a good reason for enabling this policy, and it's recommended that unless you have to, you leave this to allow so that you can avoid blocking legitimate traffic. Now you're going to notice we have a whole bunch of other things here. These are individual signatures that we can manage if we like. There's lots of them. If I right-click any of these, you're going to see that I get some options. One is to configure the signature properties. Second is to set the response to detect only. The third is to disable it. And the fourth is to flag it for attention so that I can go back and do something with it later. I'm going to go to the Configure Signature Properties item so you can see what we have here. The response policy for this particular signature is the Microsoft default, which is to set it to enabled and set it to block. If I want to, I can override this and disable the signature this way, or leave it enabled and then choose to detect only. But I'll leave it to Microsoft default. On the Details tab, I get some information about this particular signature. This particular signature has to do with Windows 2000. Can't read the whole thing. Service Pack 4, Windows XP Service Pack 1, and some other things that I'm having trouble reading because of screen resolution. The business impact for this particular signature is high, so basically if it's exploited, then there's bad things that happen. So the default status is that it's enabled and that it gets blocked, and it was originally published on 6/13/2006. This just gives you a lot of good information about individual signatures. Now, in a perfect world, all of your systems will be patched against this. After all, it's a 5-year-old exploit or a 5-year-old vulnerability. But you can see the value of this when you have newer exploits that come out. After all, this is a 5-year-old one, but what if it was only 5 days old? Microsoft probably has not yet had time to respond. Clicking Configure Signature Properties does the same thing as right-clicking the signature that I showed you before. And again, you can right-click a signature and set the response to detect only if you like, which when you do that, basically automatically makes the changes that you see on the screen. Remember, I had set it back to the Microsoft default. It's now set to detect only. Or I can completely disable the signature, and then when I go to its properties, it's disabled. Or I can flag it for attention for follow-up, And then it drops off the list here because it's no longer unflagged, but you'll notice that I have it flagged for attention. So does this actually work? Well, we're going to go find out. I'm going to go over to the Windows 7 system we've been using for Global Mantics, and we're going to test using the NIST test URL that I showed you before. And here we are at the Global Mantics Windows 7 machine, and I'm at the Train Signal site, and I'm just going to go to Internet Explorer and paste in the NIST test URL, and I'll hit the Enter key. You'll notice that I'm immediately told that the network traffic was blocked, the page cannot be displayed, and there's a problem. And if I dig a little further, I'm told that the traffic was blocked by IPS. Now, I wish that this page was a little bit more informative, and it would tell me that it would tell the user why without them having to dig through this stuff and try to decipher it. But at least the system works and protects the environment as it's supposed to. What we just discussed is a network inspection system which takes a signature-based approach that is based on fact. That is, the signature. This is basically the encyclopedia of everything that Threat Management Gateway has to block from an intrusion prevention standpoint. The additional features found in Threat Management Gateway are more intrusion detection system, traditional intrusion detection system focused, and are based on network traffic behavior rather than signatures. Basically, if Threat Management Gateway detects particular kinds of behavior, it will take steps to block it to protect the environment. TMG comes with a number of detection settings for very common network attacks, such as Wind Nuke, LAND, Ping of Death, IP Half Scan, UDP Bomb, Port Scan, and DNS attacks. You may have heard of the Ping of Death before and some of these other scares. The Ping of Death is basically a way that a ping packet can be used to bring a system down. And that stuff's kind of scary, and you want your firewall to block it so that you don't constantly get denied service. I'm not going to go into exactly what each one of these things are, except to help you understand that Threat Management Gateway can help protect against these kinds of attacks. In addition, Threat Management Gateway can help protect you from IP options issues as well as fragmentation, IP fragmentation. You can actually block packets based on specified IP options. Now, this is not like saying TCP port 43. That's a firewall rule. TCP/IP has what are called protocol numbers. And you can block based on those protocol numbers or options. And we're going to see that over on the Threat Management Gateway system in a few minutes. You can also block IP fragments. Fragmented IP packets can be used as an attack vector, but there's a huge but here. Some services don't operate well when you block IP fragments. For example, audio-video services and an L2TP-based VPN service. If you're using these services and you enable the blocking of IP fragments, you could really mess up some of your real-time audio-visual services. So it's recommended you don't block IP fragments unless you have to. So, what are some things you can do? This is going to help the flood mitigation settings help you kind of understand how behavioral protection works. It's easy to understand how the network inspection system works because you have a signature and an action based on that signature. When you have things like behavioral protection, here's some of the settings you have at your disposal. You can mitigate flood attacks and worm propagation by configuring the maximum number of TCP connections open per minute. If you see connections start opening faster than that rate, Threat Management Gateway can take active steps to throttle or block the activity because that's a sign that there could be something taking place that it's not supposed to happen. Again, that's a network behavior that Threat Management Gateway can help protect against. You can also limit the maximum concurrent TCP connections per IP address. So if some IP address is trying to open tens of thousands of TCP connections, that could lead to overflow issues, so you can mitigate that behavior. And the same goes for the maximum number of half-open TCP connections. Likewise, HTTP requests per minute per IP address can be capped or managed to help prevent against those kinds of attacks. And you can also specify maximum new non-TCP sessions per second per rule. Finally, the same thing goes for UDP. It's not just IP, TCP, that are attack vectors and HTTP. UDP can also be used. So you can actually set a maximum concurrent UDP sessions per IP address so that you don't overwhelm and potentially create an overflow situation that would leave your network vulnerable to further attack. Now, let's go over to the Global Mantics TMG system and take a look at these settings. I will note that Global Mantincs is going to make no changes to the defaults, but we want to discover where these settings are configured. Here we are at the Intrusion Prevention System, this time at the Behavioral Intrusion Detection tab. And you can see some of the options we just talked about. For example, configure detection settings for common network attacks, configure IP options filtering, and configure flood mitigation settings. If I choose the first option, you're going to see that we have a number of intrusion detection options that I mentioned before. If you're interested in learning more about these attacks, they're all available. You can get information about them on Wikipedia. Just use Google, something along those lines. Some of them are pretty interesting. If you need to, or if you want to, you can log if this happens to take place. You can log the drop packets so that you know that something took place. Then we have DNS attacks, and you can enable detection and filtering of these DNS attacks, including hostname overflow attacks, DNS length overflows, and you can block DNS zone transfers. Notice by default, zone transfers are not blocked. On the IP options filtering area, we have some options. You can enable IP options filtering or disable it if you like by deselecting the checkbox. Then you have a couple of options with regard to IP options. You can deny all packets with any IP option. You probably don't want to do that because some IP options are good. Or you can deny packets with selected IP options, or deny packets with all except the selected IP options. By default, Threat Management Gateway denies packets with selected IP options as per below. For example, timestamp, loose source route, strict source route. Those options are blocked if Threat Management Gateway sees them. Then we have the IP fragments option, which by default is not blocked, and that's because it breaks audiovisual and some VPN services. But if you need to block IP fragments, you do so here. And finally, we have the flood mitigation settings that I mentioned before. Now, each one you'll notice has either an edit or a view button. So, if I want to edit the maximum TCP connect requests per minute per IP address, I simply click the edit button and I can choose a limit. In this case, it's 600. Or I can choose a custom limit and set it to 6,000, which I did for an example here. Notice here you also get some mitigation descriptions. So if you're interested in learning about more about each individual mitigation option, go through each option here and take a look at the mitigation description area. It's interesting. And here's just a view. You can't make any changes. We also have exceptions, so you can apply custom limits to certain computer sets. So for example, you may want to allow certain services to open up as many connections as they want. Well, you can add that machine with a different rule set by clicking the Add button, choosing the option, and then making modifications to it. If you're using SIP, which is Session Initiation Protocol, it's often used for voice. You can make custom limits for your SIP parameters as well. Total number of concurrent SIP registrations, for example, is 5,000 by default on the filter for the Threat Management Gateway system. Maximum number of concurrent calls, again, 5,000. You can adjust these settings if you need to. This is the behavioral intrusion detection portion of the intrusion prevention system in Threat Management Gateway. We started this lesson with an explanation for what exactly is Network Inspection System. From there, we discovered how NIST is updated. And you learned about managing NIST settings, creating exceptions to NIST policy, and testing the network inspection system, at which point we walked through all of the various network inspection system settings that are available. You also probably got to see that the network inspection system is pretty easy to manage, and the defaults are very, very good, so there wasn't much to change. Next, you learned how to configure behavioral intrusion detection and learned a few things about behavioral protection in the process. Thank you for listening, and I look forward to seeing you in the next lesson.